Can we not do that, please? Okay, so this is week 2 and lecture 3. We're still covering the material in week 2 with basic electricity. So the flow of electrons is called what?
You said the flow of electrons?
Yeah.
Current.
Current is electricity. You're right. It's current. So current is flow, right? Like current of water is also flow. So that's flow. It's like flow of water. It happens through friction. That's static electricity. Chemical, like battery. Got it? Battery is chemical. Two chemicals combining, making electricity. Magnetic. Dominic says magnetic. That's when we use a generator. It's magnetic, and it's based on induction. Heating similar metals. Somebody realized that when we heat two metals that are different, they generate small amount of voltage. Is it enough to power a light bulb? Maybe. Is it enough to power an AC? No. Okay? So these are the 4 ways to generate electricity. Yeah.
So how would, can you give an example of like heating metals?
I'll show you an example now. But with heating metals, so this thermostat now doesn't have the coil or the mercury anymore. What they have is 2 wires. One of them is copper, and the other one is something else, nickel, and they are spot welded in the middle here. So when they meet at the tip and you heat it, every one of them will have the electrons vibrate at different level. Makes sense? Because they have different orbits, correct? This little vibration produces millivolts, small amount of voltage. That's production of electricity. And somebody evolved that into something else, and some people are trying to make it better. We'll talk about, I'll show you a picture about something practical about that. So friction is static electricity. We all face that in the winter. You walk over carpet, you touch the doorknob, and zap. If you have a cat, you always have fun with that all the time. You walk around and touch the cat, especially in the nose, and it will zap the cat. Don't do that, it's not nice. But it happens with the hair, it's friction, basically friction. And once it's balanced, there is no more. If you notice, there is no flow. So static electricity is not a good way to generate electricity because there is no flow. It's only a spark, only a charge.
Lightning?
That's, yeah, that's static actually. That is static electricity. Between the clouds, friction, and molecules, big charge, boom, all at once. That's static. Move. Batteries. So batteries, don't worry about the verbiage in here, it's a lot I know. But how does the battery work? Does anybody take apart a battery at some point? Sure you did, come on.
Take apart the battery?
Yeah. You know, you guys are good kids, huh? So,
is it made from like liquids?
no, there's little AAA batteries. You never thought of taking them apart?
How do you take apart a battery?
Where you cut it open?
Creative.
Isn't that a little tiny one?
Yeah, if you pop the top and disassemble and make a mess. If you take apart a battery, regular AAA battery, it has a paste and it has a rod. What's happening is we're combining 2 material together, and this is how you produce electricity.
Oh, so like the metal when you put the batteries in the thing, like
Yeah.
little prongs.
Yeah, yeah. If you look at the car battery, if you look inside, I don't think you can look inside anymore, but back in the days you can open we call them the eyes or something. You have 6 of them or 4 of them, and you see some water, and there's some rods of lead and something else. So again, 2 metals, 2 chemicals combined together making electricity, and this is what's happening here. So there's electrodes, and electrolyte is basically the thing that conducts them. In the car battery is the acid. In the AAA battery or dry batteries, it's paste. And I can't believe you guys never did that. So when you were young, when the toys ran out of battery, what did we do? Well, we bit on them.
Put it on the freezer.
Yeah, or you can bite them a little bit so that you can make more conductive. They can get some juice out of it, a little bit. And then your teeth get broken and it tastes really funny. Yeah. You end up being okay. So it's electrolyte. It could be a paste, it could be liquid. It's a chemical reaction that provides the flow of electrons and perform new substance. So when you charge and discharge battery, your phone battery now has lithium ion, which is like combined together using new material. When you charge it, this new material, you combine again and become, so there's always back and forth, and there's always something called the life cycle. Every time you do that, there is some byproduct that you don't want. That's why your phone battery after 1 year, it does not hold the way it used to, right? A new phone will have nice battery that lasts for 2 days, and as we do more and more cycling, this material doesn't go back and forth as much. That's a rechargeable battery. The dry battery that does not recharge, you can do it only one way. That's why it is cheaper. Dry cell, that's what they call dry cell, is made out of zinc as a negative electrode to give away electrons. Manganese dioxide is the paste, that messy paste that you, I'm gonna take away part. I'll bring a battery next time, I'll take it apart. This is fun. And carbon rods to collect the electrons. So I have a better picture here. Yeah. So if you look at the battery, this is the dry cell battery, a Duracell energizer. This is the rod that goes up to the positive, and this is the paste in here to connect two things together. They have spacers, and inside there's the zinc electrode. And once you connect those two together, you have made a complete circuit. What is a complete circuit? Everything is connected together. So we connected the positive, negative, and then you'll get electricity and flow, and the light bulb will turn on. Questions? That's a simple idea of battery. And that's what kind of electricity?
DC.
Chemical. And it's DC, you're right. It is DC. Don't jump the gun, they still don't know that. We'll talk about DC and AC
You
for a
just
moment.
asked.
It's DC. It is direct circuit because we're getting a flow of negative into the positive going until we run out of the paste. Thermoelectric is what we talked about. It's the thermocouples. I wish I could show you. I don't know how to make tools with me. Anyway, it's a wire that will generate millivolt based on temperature. And I'll bring some props and we'll work on it. Most sensors now for temperature are thermocouples. 2 wires, you'll see it, a small little wire that senses the temperature. How does it sense temperature? It actually makes voltage, and we put the right voltage with the right temperature. Dissimilar middle, you can see the thermostat of thermocouples. New types are always being invented to make them more faster and generate more electricity. This is the guy who invented it. He generates current in conductive material. Each material generates different amount of current. Different current means different voltage. So there's different current in each one of them. There's voltage coming out because, again, we said when you give something energy, the electrons will vibrate more, and if they vibrate at different level, there's different current, and that will give you voltage. Calibration, how do we measure temperature out of thermocouples? Is when we measure the voltage that produced at that temperature and record the temperature. And we'll talk about that again when we get to it. So this is an example of, I don't know who asked me about an example of thermal generation. This is one of them. A lot of campers use this thermopot. So what happens is you fire from the, you put in a bonfire or you heat it, and there's a lot of similar minerals here, and it's designed to give you enough electricity to charge your phone. It's not, again, it's not a lot. Even though you're putting fire underneath, a lot of heat, it's not going to generate a lot. It's very small. It's enough to charge your phone, but it's not enough to turn on a big 60-watt light bulb. It's all thermopots, and I know a lot of campers have that. It got a little bit, people trying to harvest more energy from heat, but it's not as the same as mechanical. Again, this is thermocouples, two similar metals connected together. Once they heat it, they create voltage. So, electricity through magnetism. That's what we depend on now. It's the relationship between magnets and current, and how we can change mechanical movement and mechanical power into electricity. That was the breakthrough into power generation. But we can turn this humongous power of water and wind and an engine into large amount of electricity. So, and that was the motor principle. So there's a video we're gonna watch. It's an hour video, but we're gonna cut it to pieces. It's very corny, but it's very, very descriptive. It's the best video you can find that actually explains to you what is electricity, how did it come through, and what is the relationship between magnetism and electricity. How did we come up with this great invention? How would somebody like think about that? It's amazing. And if it wasn't for that, we'll still be using DC power. I mean, using batteries. And batteries actually dated back to the ancient Egyptians. So 3,000 years ago, they had batteries. They used acids in jars to make batteries. So it was always there. Also there were some scientists who tried to study sea eels, the particular eels, to get some charges out of them. That was very common as well. And it's amazing how they make this huge current in them. Again, it's a chemical reaction. A lot of insects do that too, chemical reaction, make electricity. It's very fascinating. Or also fireflies, they have a chemical reaction that make light. So there's a lot of creatures who actually did that before us. Conductors and insulators. So going back to the periodic table, we said conductors have more loose electrons than others, so they can give electrons and take one. They're more loose, so they can be knocked out and in. Elements with full last orbits are insulators, and they are carbon-based. I said rubber, plastic, wood. Is it the same for heat and electricity? If something conducts electricity, does it also conduct heat well? Yes. If you notice, metals conduct heat very well, and they also conduct electricity very well, so it's the same. What are metals? Metals are alloys. What's the difference between an alloy and metal?
Alloy is a mixture of metal, right?
Yeah. So when you say alloy wheels, it's the mixture of other stuff. Metal, just one type. Could be iron, could be steel. What is steel?
Steel?
Yeah.
Like a type of metal.
Connection,
A
iron
combination-
and carbon.
Yes. It's a combination between carbon and iron. That's steel. Depending on the curing process and how it's mixed, you have different kind of hardness of steel. Because pure iron is kind of soft. It's softer than steel. Steel is harder. So we put some carbon with steel.
So what are metals again?
Huh?
What are metals again?
Metals are material that conduct electricity, ferrous material, non-ferrous material, and they're in the middle of the periodic table. So the short answer is conductors, material that conduct electricity, and they're metallic. What are insulators? Material that do not conduct electricity well, like plastic, rubber, carbon-based material. What about semiconductors?
Things that kind of conduct.
If I say semiconductor, what element comes to mind? Silicon valley. So silicon is one of the common top types of semiconductors. What do semiconductors do? They're moody. They can conduct and non-conduct. The thing is, if you energize them, they will conduct. If you don't, they don't conduct. So that became a really breakthrough in electronics on how to make switches. Instead of making mechanical switches, we can use semiconductors, and we'll talk about that later. So they can either conduct or not conduct depending on their state. Silicon, ceramics, sand, they're all semiconductors. Is there a perfect insulator? No. What about air? Is it no, it's not an insulator. And you can see spark jumping. Lightning is jumping through air. We will actually depend on that to do ignition. We have a spark jump through, 2 prongs to ignite stuff.
What about oil in a transformer, in
Yeah.
a big transformer?
Yeah.
Is this like not conductor, right?
What do you mean between the two? What kind of transformer?
Big transformer has oil inside.
Oil.
Yeah.
Oil?
Oil doesn't conduct.
I don't understand the question. It has wires inside, not.
Yeah. What was the question on the previous page?
The paste?
What is perfect insulator?
Yeah. There is no way it will conduct at any voltage. Because everything conducts at some voltage. Even rubber, if you put a lot of voltage, it will go through. So it has to be a lot though. like tens of thousands, but it will go. So eventually, at the end, everything will conduct. At some point, even air, even vacuum, at some point it will conduct. It will go as a wave. All right, we'll stop this video and thank.